Scrummy donuts are modelled by the circular region bounded by the circle x minus 3 squared plus y squared equals 4, being rotated around the y-axis to produce a donut-shaped object called a torus. All dimensions are in centimetres. Show the volume of this donut is given by the integral from a to b, 12 pi root 4 minus y squared dy. State the values for a and b. My immediate thought here is that what we're going to do is something of a volume of revolution using sort of two halves of the circle like this, where I'm going to call this distance here small r and the other half we'll call it big R, and so we're going to have a sort of r squared minus r squared thing going on. But let's look at it more specifically now. So from the equation we have x minus 3 squared is equal to 4 minus y squared. I'm just looking at this here and thinking about how we're going to go about getting something of that nature. So x take away 3 would be plus or minus the square root of 4 minus y squared, and that's going to give me my r and my r, I'm pretty sure. So x is going to be 3 plus or minus the square root of 4 minus y squared. And because I called big R the bigger radius, that's going to be a 3 plus root 4 minus y squared, and the r is going to be 3 take away root 4 minus y squared. Now you can see why we're going to have this r squared minus r squared, because if I do just the big R squared, it would give me a volume that's like that. So I'm going to have to cut away this volume here, which is why I've got the minus r squared. So let's think about that now. So r squared would be 3 plus root 4 minus y squared, square that. If we expand that, we're going to get 9 plus 6 root 4 minus y squared plus 4 minus y squared, and that is going to give me 13 plus 6 root 4 minus y squared, take away y squared. If I do the same sort of thing for r squared, we can see the only difference is the minus there. So it's going to give me this. And then if we do r squared minus r squared, that is going to give me 12 root 4 minus y squared. So that is great. The pi is just going to come from our formula, isn't it? So, sort of pi times the integral of x squared dy, thinking about the fact that we're taking the r and the r in the horizontal direction. And so that is going to do it, I think. That is going to give us our pi, and the 12 comes from over here. Then we've got the root 4 minus y squared dy. And if we think about the y values, they go from -2 to 2, just on the diagram there. And so that will be -2 to 2. And so we get that a is equal to, was a the bottom limit? Yeah, -2. And b is equal to 2. So I think that does it. Nutritional information about scrummy donuts. Average density is 0.28 grams per centimetre cubed. Health recommendation, no more than 180 grams to be eaten per day. Eat responsibly. So calculate the maximum number of scrummy donuts that can be eaten each day if the health recommendation is to be followed. So the first thing we want to do here is evaluate the integral we had up there. Integral -2 to 2. Probably easier on your calculator to put the 12 pi inside. Root 4 minus y squared dy. If you evaluate that on your class pad, you'll get 236.8705 and so on. And then we are told 0.28 grams per cubic centimetre. So if you then multiply that answer by 0.28, you'll get 66.323. Now, told 180 grams maximum, so if you do 180 divided by the 66.323, that comes out at about 2.713. So if you're going to go to the whole number, you'd say no more than 2 donuts, but they accepted 2.7 as an answer.